evening, everybody, and it's a privilege to be here to present to you today on the Kubernetes Gateway API and how it is going to impact our lives in the API space going forward. So thanks a lot for being here. So I'm going to talk through a bit about the Kubernetes Gateway API and the changes we are going to be seeing in the modern world in the space of APIs. So it's going to be a bit of a technical session at the beginning, and then we move towards kind of like strategy to discuss how we should prepare ourselves for the upcoming changes. So before we start in, this is me. My name is Nuwan Dias. I work at WSO2 as a deputy CTO, also author of a book and a speaker at various events. So that's my LinkedIn and Twitter handle over there. So if you'd like to get in touch, I'm more than happy to. Okay, so just to get the tires warmed up, I'd like to give you a reminder of how we got here in the first place, right? About today we are dealing with API gateways and lots of stuff, but here's where it all started, right? So back in the 80s, we started with network converters, and then we had the introduction of big IP, hardware load balancers, and then proxy servers such as the Apache HTTP server, which I'm sure most of you are familiar with. And then towards the 2000s, we saw the introduction of software load balancers, so HA proxy, for example, right? And then we had ADCs, like so Nginx, Citrix ADCs, which became popular at the time. And then we saw the emergence of enterprise service bus, right? So that was very popular during those stages. And towards 2010-11, we saw the emergence of API gateways becoming very popular. So Apigee was a pioneer back in the day, and then we saw API gateways from WSO2, and then today there are tons of API gateway providers in the market. And as microservices became popular, we saw these gateways converting into micro gateways, right? And then they have led to the emergence of cloud native gateways that we see a lot in the market today, right? So that's basically how we evolved into where we are today, right? So when you're talking about becoming cloud native and how we operate on the cloud, right? So most of us become Kubernetes and use Kubernetes. So just to remind you of how this networking works inside Kubernetes. So this is basically a typical network architecture that you would use on Kubernetes, right? So this is not the only way to do networking, but this is a typical architecture. So this big box that you see, the green colored one, is your cluster. So a cluster is comprised of several nodes. So these can be physical or virtual nodes, and a given node can consist of one or more services. So as you can see here, service 1 is replicated across 3 nodes, service 2 the same, right? And then in order to get traffic into your cluster, we usually have something called an ingress controller. So an ingress controller can typically be inside the cluster. It can be outside too, but most likely it will be inside the cluster. So you get your traffic into the cluster through the ingress controller, and that's what load balances between your services. So if you look at the client application, so your client application, which is sitting somewhere outside, will talk to your application services, where the DNS would resolve to an IP address of a load balancer. Load balancer would forward requests to the ingress controller, and that's how you'd get the traffic, right? So like I said, there are different ways to get it done, but this is one of the most common or popular ways you do it, especially if you have a sizable cluster, right? So that's basically how you would do it. Now, talking about ingress controllers, so the Kubernetes, there's a spec called the Ingress API in Kubernetes, and this is what that spec looks like. So since we are here at an API conference, when we talk about APIs, we most often talk about OpenAPI, GraphQL, and these kinds of things. But this, as you know, Kubernetes APIs are declarative, so they take a YAML format. So this is the spec of the Kubernetes Ingress API. Now this has, as you can see, 2 rules. One which is routing a request on the host api.example.com to the default API service, and the other which is routing anything on /admin to the admin service, right? So that's like a very simple API for handling ingresses. Now, the problem with ingresses is that they don't have all the features that are needed for modern cloud native applications. They have a set of limitations, and these are some of the limitations. It supports HTTP only. So if you want other protocols, you have to look for workarounds. It has limited matching rules. So if you Remember, it supported only host and path-based routing only. So if you want additions, you have to do custom annotations, right? So custom annotations is a problem because what that makes the API is it makes the API vendor specific, and therefore it becomes non-portable. So if you look at Nginx, for example, they have a set of custom annotations for additional routing rules, but now those cannot be used on an HA proxy, for example, right? Because HA proxy doesn't understand it. So these lack of features have eventually led into a non-portability of the API, right? So ingressors typically work on only one namespace. So if you have more than one namespace, you have to look for workarounds. And then there is no separation of concerns. So if you go back, if you observe this API, you can see that there is a part that is handled by your platform team, so defining of the ingress, and then there's a part that is handled by the application team. The application team would define all the routes. The platform team would define what kind of ingress to use in your cluster. But in this API, all of them are together. So what happens in practice is that the application team ends up dealing with platform stuff as well, which is not good. So these are some of the limitations in the ingress API. Now to address this issue, the Kubernetes community, they came up with the idea of a Kubernetes Gateway API, which addresses most of these issues that we have been talking about, right? So first of all, it has a resource model. So the Kubernetes Gateway API has like 3 main sections. The first is the gateway class section, which is defined by the infrastructure providers. So your infra providers will define what kind of gateway you should use in your cluster, right? And then you have the gateway, which attaches to a gateway class. So this is handled by the cluster operators. And finally, you have the routes, which are handled by the application developers. So this way you separate out the concerns, and this immediately gets rid of the separation of concern problem that we had in the ingress specification. So you now have a very clean API where each team can work on their parts in isolation without impacting the other. So these are again some examples. So this is part of the API where the network, or rather the infrastructure providers, deal with. They specify the kind of gateway to be used in your cluster. And then here we have the cluster operators who define the gateway, attach it to the relevant gateway class, and then they define the settings of the gateway, like what kind of protocols to use, what kind of routes to allow, and so on. So this is basically done by the cluster operators. And finally, we have the application developers who work on the routes only. So they don't mess with the kind of gateways or their settings. They simply work based on the rules required for their applications. So this way you have a very clean set of separation, and you don't mess with each other's work, right? So that's how that problem is solved. Now, so if you do a comparison between ingress and gateway API, so this is what a comparison would look like. So ingress supports basic HTTP routing only. Gateway API supports more advanced routing such as weighted routing, header-based matching, and so on. Extensibility wise, you have to use custom annotations with ingress. Gateway API provides an extension mechanism through custom resources, which makes it portable. So lots of vendor specific annotations in the ingress, but the gateway API has a universal standard. Separation of concerns is non-existent on ingress, but in the gateway API you have it by design. So HTTP only on ingress, the gateway API today supports these protocols, but the beauty of it is that it's extensible, so you can keep on adding protocols without messing up the current API. Security, you have TLS termination, but the gateway API supports more advanced security options as well. Now, getting into the world of API management, so one key thing to understand here is the difference between the gateway API and the API gateway. So mathematically this would be true, but in our context this is not true. And the difference is something like this, right? So if you look at a train schedule, the maps and the tracks, right? So if you look at a train and a train scheduling system, the train schedules, the tracks, the paths, the stops, the stations, they are all defined by a transport authority in a country, right, or in a city, right? But the actual trains are provided by different companies, right? So the trains can be, some companies might provide electric trains, some companies might provide diesel engine trains, whatnot, right? But no matter what trains you provide, all these trains have to adhere to the schedule and the routes set by the transport authority in the city or the state or the country, right? So that's the difference between these two things. The gateway API is like the schedule, the routes, the paths, the stations, right, the stops. And the API gateways are like the trains. They can be provided by different vendors, but they have to adhere to the specification given by the authority, right? So that's a key thing to understand in this space. Okay, now since we are in the space of API management and API gateways, you have to think about, okay, what capabilities does an API gateway need? Now if you think through that and then take a look at the Kubernetes Gateway API spec, you will realize that it still doesn't meet all the capabilities you need to do proper API gateway stuff, right? So, so things like JWT based authentication, rate limiting, they are non-existent on the spec. So to solve this problem, the Envoy community, the Envoy proxy by the way is like the most popular proxy in the Kubernetes ecosystem. The Envoy community came up with the concept, this idea called the Envoy Gateway project a couple of years ago, right? So this addresses the limitations of the Kubernetes Gateway API and makes it possible to use it for API gateways. So as I said, the Kubernetes Gateway API is an extensible API, right? You can add to it without messing with it. And this is exactly what the Envoy community did. So this is a sample of how you add like security or OAuth 2 based security on top of the Gateway API. So as you can see, there's a custom resource called security policy define, right? And you can define this custom resource and attach it to the gateway kind in Kubernetes. So you can see how the API has been extended without messing with it, with its core structure. So the Envoy Gateway project came up with a way to do like rate limits and other features that you need on an API gateway. So the benefits, so if you go through look at the benefits of, what are the benefits of using the Gateway API instead of directly going into an API gateway configuration, is that the first of it is standardization and consistency, right? So the Gateway API gives a level of abstractions to developers. So these developers now no longer have to worry about configuring API gateways. They only have to worry about adhering to that standards for defining their APIs. So that makes them focus on the what and not on the how, which is a huge win, right? So it gives better manageability. So as you saw through the examples, since this is a Kubernetes API, it follows a declarative approach. So the benefit that gives is now as a developer, you can declare the desired state of the system. You have no responsibility of getting it to work. Your responsibility ends at the point of declaring the desired state of the system, and the controllers that are running will make sure that the system is brought to that desired state, right? So it also makes APIs a first-class citizen on Kubernetes. So similar to the other resources like services and deployments, APIs now become a first-class citizen in the Kubernetes ecosystem. And also it brings a lot of flexibility and extensibility. The beauty of this is now, consider you're an organization that uses one gateway provider for a set of services, right? And for a new set of services that you want a different kind of gateway provider for whatever reason. Now, in the past, this would have been a huge headache because now you have to change, when introducing a new gateway, you have to change the way how your application developers work, because they now have to worry about how to configure this new kind of gateway. So you end up with two ways of working inside the organization. And that problem is completely gone, right? So now if you want to introduce a new gateway or if you want to migrate from the old gateway, it's a breeze. Application developers don't have to do anything. They can keep continuing working the way they have been, right? So because they now operate on a standard and don't have to worry about the how to configure part of it. So it's a future-proof. It gives them a future-proof way of working. And what does this mean for modern API management, right? So two main things primarily. So it gives a vendor-neutral control plane for APIs. So a big problem that large organizations are having is that different parts of the organization, like different departments, different teams, they end up using gateways from different kinds of vendors. And that makes them end up in a situation where you have a mess now, right? Because each vendor has its own control plane, has its own discovery portal. So you have APIs spread across your organization, but no one place of discovery, no one place of policy enforcement, it becomes a mess, right? So what this standard is enabling is the ability to have like a universal control plane and discovery portal and all that comes along with it for any kind of gateway that's running in your ecosystem, right? So that's a huge win for organizations. Another interesting thing that's happening is that along with this specification, API gateways are basically becoming part of the woodwork. It's becoming invisible because you now focus on the API standard and not really on how to get the gateway to work. So it's becoming invisible. It's like it's not disappearing. It's disappearing from sight. It's there underneath, but it's disappearing from sight, right? So that's another big thing that's happening, and it elevates the developer's experience of working with APIs, which is what they should do, right? It's not their developers' job to make API gateways work. It's the vendor's job, right? So their job is to focus on their business logic, on the actual APIs, right? So that's what this is enabling. So how should you prepare? So if you're an API provider, if you want to use an API gateway, or if you're thinking of upgrading or switching to a gateway, one important thing to keep in mind is to shift to using a gateway that supports this standard, right? Because that's where the world is heading towards. So you should use a gateway that is supporting this standard. And one other important thing is to have a clear separation between business logic and API gateway, right? So the moment you put an API gateway in front of your services, right, people start becoming lazy, right? Because now these gateways allows manipulating your messages, doing various kinds of things. So when you get a new business requirement, instead of modifying your service, there's a tendency to go and embed those business logic in the gateway. Now, that's not a very good thing to do, because it ends up in a situation where you have business logic running in your gateway, and the moment you do that, now your gateway becomes non-portable again, right? So that's not a very good thing to do. So have a clear separation between these two things. And with the concept of this universal control plane, so you have to treat API publishing and deployment as two distinct practices, right? Now previously, since the control plane and the data plane were both provided by a single provider, you could think of these two things as a single operation, publishing and deployment. But now it could well be possible that your control plane comes from one provider and your data plane comes from many different providers in the context of APIs, right? So you have to treat these two things as distinct practices and use vendor-specific extensions carefully. So if vendor-specific extensions require you to change your configurations or use custom annotations, that's not a good thing, because then again you end up in the ingress-like problem where you have the API becomes non-portable. Right, so finally, so we see this happening not just in the API management space, but across all practices of the cloud native landscape. So there's this emergence of internal developer platforms. I'm not sure if you have heard it. So there's this emergence of internal developer platforms where their primary goal is to elevate the experience of developers, of application developers, to a level that they focus on the business logic or their primary task only, right? So what that means is they don't have to worry about CI/CD, they don't have to worry about setting up observability monitoring anymore, they don't have to worry about API management and analytics anymore, right? So that is what these internal developer platforms are trying to achieve. So this development in the API space is really helping this goal. So what is happening, as I mentioned before, is that these configurations and API gateways, they are basically disappearing from sight. They are not disappearing physically, but they are disappearing from sight. And what that enables organizations and developers is that it gives a huge productivity boost to the developers, because they can now offload all of these things, like which CI/CD tool should I use, which monitoring tool should I use, which log analytics tool should I use, right? All of these things are now translated into a platform, and that gives them a lot of time and ability to focus on what is core and value adding to their business. So this is another development we are seeing in this space. So if you're looking into modernizing your organizations, this is the direction that you should be looking towards, right? So with that, I'd like to conclude my message for today. I hope it was a useful session to you all. Thank you.